I'm going to do a couple simple examples using the sine law. So the sine law works when you know an angle and the side length across from it. It doesn't work otherwise because you have too many unknowns. But as long as you know one of the angles and you know the side length across from it, you can use the sine law. We use the sine law to solve triangles when we don't have a right angle. That is, if we don't have a 90-degree angle. The sine law is the sine of angle A over side length A is equal to the sine of angle B over side length B. And I could also say that's equal to the sine of C over C as well. So what that means is the sine of this angle divided by this side is equal to the sine of that angle divided by that side, and likewise equal to the sine of this angle divided by this side. If you're looking for an angle, you'll want to use it like this. If you're looking for a side length, you'll want to put the side length on top. So A over sine A is equal to B over sine B. Now, there's a double convention here. That is, you use a capital letter to denote an angle, a lowercase letter for a side length, and you use the same letter for an angle and the side length across from it. And that's used consistently in trigonometry for sine law and the cosine law. So let's solve this question here. I've got an angle of 97 degrees across from a side length of 12, and I've got an angle of 42 degrees and a side length d, and that's unknown. So using the sine law, it's as if this is A, that's angle A, that's angle B, and that's side length B. So I will go A over sine A is equal to B over sine B. Now, once you get good at this, you're not going to need to waste time with this step writing that out. So A is my unknown side length D, and the sine of A is the sine of 42 degrees. B is my known side length of 12, and the sine of B is the sine of 97 degrees. So I now can rearrange this by multiplying both sides by the sine of 42 degrees. So D is equal to 12 times the sine of 42 degrees divided by the sine of 97 degrees. So side length D is equal to 12 times the sine of 42, and I'll use my trig table here. The sine of 42 is 0.6691. And the sine of 97 degrees, now there's a trick here. Notice I don't have 97 degrees. This table only goes up to 90 degrees. However, the sine of 180 minus any angle is equal to the sine of that angle. So that means the sine of 180 minus 97 is equal to the sine of, the sine of 97. 180 minus 97 is 93. So if I need the sine of 97, I can subtract 97 from 180, and it's the same as the sine of 93. Oh, sorry, 83. I did my subtraction incorrectly. And the sine of 83 is 0.9925. So I'm going to put in, for the sine of 97, I'm going to use the sine of 83, and that's 0.9925. You can verify that with your calculator. So I'm going to find the sine of 97, and it's 0.9925, just as we found using our table. So this is now going to be 12 times 0.6691 divided by 0.9925. And that gives you 8.09. So D is equal to 8.09. So to recap, if you know an angle and the side length across from it, you can write down the sine law. Then fill in all the information that you have. It's often useful to relabel your triangle using A and B so that things line up perfectly with your law. If it's a side length you're looking for, write out the sine law with the side lengths on top. In the next example, it's going to be an angle you're looking for, so we'll write it out with the angles on top. You then put all of your values into the sine law, and you apply a bit of algebra. You can use your calculator or a table. I prefer to use a table to find the sine of the given angles. And if you're looking for the sine of an angle greater than 90, follow this simple rule. If you take 180 degrees and subtract the angle you're looking for, it's equal to the sine of that other angle. That works with sine law. It doesn't work with cosine. There's a different trick we use for that. So here's an example where we're looking for an angle. Again, I'm just going to quickly relabel this using A and B. So I'm going to call that angle A. And remember, side length A is across from angle A. That's going to be angle B, and that will be side length B. And just make sure it's A is across from A and B is across from B. The sine of A over A is equal to the sine of B over B. I'm using this form of the sine law with the angles on top because it's an angle I'm looking for. I'm then going to write in the values. The sine of A divided by 8 is equal to the sine of 50 divided by 12. I'm then going to find, well, I can rearrange it first. I can multiply both sides by A. So the sine of A is equal to the sine of 50 multiplied by 8, and then I'm dividing by 12. So the sine of A is equal to the sine of 50, which is 0.766, multiplied by 8 and divided by 12. That's 0.511. So the sine of angle A is 0.511. So I'm going to look through my sine column for the closest I can find to 0.511. And I think this is it right here, 0.515 or 0.5. The sine of 30 is 0.5. The sine of 31 is 0.515. So 0.511 is right in between them. So I'm going to say it's 30.5 degrees. So if the sine of A is 0.511, then angle A is 30.5 degrees. Now we can get better accuracy using a calculator. The inverse sine of 0.511 is equal to 30.7 degrees. The best you're going to get with a table of values is you're going to be sure you're accurate to within a degree, and when you guess, you're probably accurate to within half a degree, which is generally good enough. But you can get a perfect answer using a calculator. That's 30.7. So to recap, the sine law works as long as you know an angle and the side length across from it. And you can use it to find either another angle or another side length, as long as you have another piece of information. The sine law works even when you don't have a right angle triangle. If you have a right angle triangle, you're going to use SOHCAHTOA. It's just quicker and easier. If you have a table instead of a calculator for your trig values, then all you've got to do is subtract the angle you're looking for from 180 degrees to find the sine value. Oh yeah, remember, if you're new here, smash the like button and subscribe.